Okay, guys, we're going to move into experimental probability. We'll do more with experimental probability, like predicting like unknowns in the future. But for right now, we're just going to talk about experimental probability, do a couple of experiments, and use them. All right, so experimental probability is a probability based off an experiment, which we're going to conduct. Sorry, my pen's not on. There we go. And in order to do that, we're going to flip a coin 36 times. And I have a digital flipper over here, so I'm going to do it 36 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, just double checking, 5, 10, 15, 15 and 6 is 21 times. Okay. 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. Oh, that one didn't count because I only went 36. Okay, just double checking. So I got 15 on here. 5, 10, 15, 5, 10, 15, 20, and then 21 here for a total of 36. Okay, and now we're also going to do a random number generator. Random number generator. If I had a die to do this, I would do that for you. So 12, 36 times. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Okay, I'm just going to double check. So it's 1, 1, 5, 3, 3, 5, 3, 4, 1, 4, 3, 3. All right, so that totals 1, 2, 7, 10, 7. This is 18. Just making sure that I have a total of 36. 7, 8, 8, and 7 is 15, and 18, 18. Okay, so I got all 36 registered. Just double checking. All right, whew, that was a lot. Now, I'm going to close that down because I don't need that anymore. We're going to use the experiment to find some probabilities, okay? So based off our experiment, find the probabilities. What is the probability that we get a 3? So that must be talking about the die because there's no 3 on a coin. I just wrote this. Die. So let's take a look at the 3. I see that I have 5 threes out of a total of 36 flips. That does not reduce. Now I guess it's time for me to have my calculator up. 5 out of 36, just so you can see it does not reduce. And then changing it to a percentage. Whoa. So that's a 13.9% chance. So theoretically, you would have, theoretically getting a 3 would be 1 3 out of 12, which let's see what that is as a decimal. Oh dear. There it is. Oh dear again. There, theoretically, I only have an 8.3%, but based off our experiment, we have a 13.9. Now let's do the probability of getting a heads based off our experiment. So let's see, how many times did I get a heads, right? I got a heads 15 times. So this looks like the coin. So I got a 15 out of, I did it 36 times. 15 divided by 36, math, enter, enter, turns into 5 over 12, which 5 over 12 times 100 is a 41.7% chance. So theoretically, right, if you did the theoretical heads, you would have a 50% chance, but an experimental, so this is theoretical probability, experimental probability based off our experiment, it was only a 41.7. Now I see the word, we have two things going on. So what's going to be my probability of getting a heads and getting a number greater than 8? So that would be 9, 10, 11, and 12. So how many times did I get a heads? 15 times out of 36. And then separately, I'm going to do another action and I'm going to get greater than 8. So that would be, let's see, 1. So it's everything greater than 8. So it's these ones. So it's 1 plus, I didn't hit 1, 1 plus 4 plus 3 plus 3. So that would be an 11. So there were 11 things out of 36. So these numbers happened 11 times. So 15 out of 36 times 11 out of 36, math, enter, enter, is a 55 out of 432. So 55 out of 432 times 100 is a 12.7% chance of happening. Okay, and then but like theoretically, getting a heads, that would be a 1 out of 2 times something greater than 8. That would be a 4 out of 12. So it's interesting that they don't match, right? Because theory is different than an experiment. Like things that we do in real life don't always follow the perfect theory. Okay, so let's do the next one. Tails. So I'm going to see how many times I got a tail. Remember, this is based off our experiment. And then how many times I got a 4 or a 5 on my number die. So here we go. So a 4 or excuse me, a tails. How many tails did I get? I got 21 tails. And how many times did I get a 4 or a 5? Let me get rid of this highlight and this highlight. And then a 4 or a 5 would be 3 and 3. So I'm going to put a 6 there. So 4 happened 3 times, a 5 happened 3 times. 21 out of 36 times 6 out of 36. Math, enter, enter, is 7 out of 72. 7 out of 72 times 100 is 9.7%. Okay. Oh, multiple of 2. Well, since that's dealing with, that must be talking about the number die. And the multiples of 2 are 2, 4, 6, 8, 10, and 12. Whew, that was hard. And then a heads. I think a heads, I remember it being 15 out of 36 on our experiment up here. See how it was 15? And then a 4. So I need to go look at the die and see how many times a 4 happened. All right, so let's do the multiple of 2. So I need, how many times did I get a 2? How many times did I get a 4? How many times did I get a 6? I'm going to move these up here. That's fine. I can do that. Okay, so let's zoom out. How many times did we get a 2? 1 time. I'm going to change that to a different color. So I got a 2 1 time. How many times did I get a 4? 3. How many times did I get a 6? 5. How many times did I get an 8? 4. How many times did I get a 10? 4. How many times did I get a 12? 3. Whew. So that total fraction is 1 plus 3 plus 5 plus 4 plus 4 plus 3. That's 20 out of 36 based off my experiment. And then how many times did I get a 4? 3 times. So that's 3 out of 36. So you're going to take your first fraction, I'm going to highlight them all because they're getting lost. Multiply your fractions. So 20 out of 36 for the first thing, times 15 out of 36, times 3 out of 36. Oh dear, not mode. Not math. Enter, enter. Oh, that's so ugly. So the final answer is 25 out of 1,296 times 100, which is the percent of 1.9%. So very, very, very unlikely actually that would happen. I think I did everything right there. Huh. So that was lower than what I thought it would be, honestly. Just taking a look, 20 out of 36, making sure I did my math right. Yeah. Wow, that's a lot lower than what I thought it would be. Okay, let's erase all those extras up here. This is too much for me to look at, these purples. So greater than 1 and heads. Greater than 1, ooh, greater than 1 is all of this stuff. So it would be 1 plus 5 plus 3 plus 3 plus 5 plus 3 plus 4 plus 1 plus 4 plus 3 plus 3, which should just be 35. So that happened 35 times out of 36 times, something being greater than 1. And the heads happened, I remember, 15 out of 36 times. So 35 out of 36 times 15 out of 36. So I have math enter, enter. 175 out of 432. 175 out of 432 times 100 is 40.5%. All right, a heads or a factor of 6. So the heads was 15 out of 36. The factors of 6 are 1, 2, 3, and 6. So let's see, how many times did I get a 1? 1 time. How many times did I get a 2? 1 time. How many times did I get a 3? 5 times. How many times did I get a 6? 5 times. Zooming in here, let's see, that's 1 plus 1 is 2, plus 10 is 12 out of 36. So I'm going to multiply my fractions together. 15 out of 36 times 12 out of 36, math enter, enter, ends up being 5 out of 36. 5 out of 36 times 100 is a 13.9%. The rest are going to go and do the same things. Probably the hardest part for you guys is going to be like know your multiples or stuff. So let me just tell you, if we went through this, the factors of 10 are 1, 2, 5, and 10. Let's see. Oh, let's do this next one. It says probability of heads and heads again. So you would take our experimental of 15 over 36, and then on this one you would do another 15 over 36, and I can do that just so you see it. That's 25 over 144. You can change that to a percent. I've done that plenty of times. And then a 5 or a 6 or a 7. I think you're okay. Let's talk about this one, the multiple of 4 thing. So if you were doing this one, multiples are 4, 8, and 12 on your number die. So you would have to say, I got a 4. How many times did we get a 4? 3 times. I got an 8. 4 times. I got a 12. 3 times. So that would be, let me shrink that down. That would be a 10 out of 36 for this entire item right here. And then a multiple of 6. Oh, multiple of 6. So we'd go back to our number die. 6 and 12. So how many times did we get a 6? We got a 6 5 times. And how many times did we get a 12? We got a 12 3 times. So that would be 8 out of 36. So it'd be 10 out of 36 times 8 out of 36. Math, enter, enter. So it'd be a 5 out of 81 chance. And then I'm a little concerned. I'm just concerned about your vocab. I'm not concerned necessarily about your probability skills, but maybe just your vocab. So like a prime number that, let's see, let's think about our number die. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Those are your prime numbers. So you would have to say, oh, I got a 2. How many times did we get a 2? One time. I got a 3 5 times. So 1, 5. I got a 5 3 times. I got a 7. How many times did I get a 7? 3 times. And how many times did I get an 11? 3 times. So you would add all those up, how many times those numbers happen. So it'd be 6, 9, 9 and 6s, you would say 15 out of 36 there. And then tails would be 21. We didn't do a lot of tails, huh? 21 out of 36. Okay. And then you would multiply 15 out of 36 times 21 out of 36. Math, enter, enter. And you get 35 chances out of 144. Again, are these theoretical probabilities? No, because what we're doing is we're basing our probabilities based off of our experiment. Okay, so just like one more. Factors of 12, just to go over your definitions. Factors of 12 are 1, 2, 3, 4, 6, and 12. But in multiples of 12, the only one on your number die that's a multiple of 12 is 12. So you would have to say, oh, a 1 happened this many times, a 2 happened this many times, a 3, a 4, a 6, a 12. They happened this many times, and then you would add them up. All right, now let's get one of those old school reviews going here. All right, absolute values can never be smaller than 0. Can't have a negative absolute value. True or false? Absolute values can equal 0. Well, absolutely they can. Isn't the absolute value of 0, 0? Absolute values can never, sometimes, or always be greater than or equal to 0. They can always. That is a rule. I had to think about that. So it says greater than or equal to 0. So in other words, they either have to be positive or they have to be 0. That's true. You can't have an absolute value of something and it's negative. Which one of these is all real numbers? In other words, which one's true all the time? Well, what I'm going to do is I'm going to say anything smaller than 0 is not true all of the time. Those are automatically out because absolute values can't be negative. These ones would say negatives are okay. Those ones are out. Now, are absolute values always greater than 0? Not necessarily, because remember, sometimes they can equal 0. So A is your answer. If you have something greater than or equal to 0, that's always going to be all real numbers because that's just the definition of absolute values. Okay, which one is there no solution for x? Remember, no solution would mean that it would be negative. Well, that means positive. That means positive. Ooh, that means negative. And that means negative and 0. So those ones are solutions. So it's between these ones. So which one has absolutely no solution? C. Because D has a solution. D is allowed to be 0. Now, last one, we're going to graph this. In fact, we don't even need to graph it. It says that it's, oh no, this one is actually really important to do because some people are going to want to skip this and we can't. Okay, I was going to write all real numbers, but it is not all real numbers. It is not all real numbers. So we add 6, just like we've been doing. 2x is greater than 6. Divide by 2. X is greater than 3. Okay, this one you're going to add 6. I know I wrote negative 0. That's probably bugging some of you out, but whatever. Okay, it's still 6 divided by 2. And you might say, Miss Langeli, I just got the same thing. But actually, you really didn't. Let's say this was 0, 1, 2, and let's say that is 3. Okay, so both of them are open circles at 3. One of them goes to the right, one of them goes to the left. So this is the solution set for this one. So it's almost infinite solutions, almost, but it's not because 3 is not a solution. So it's all real numbers except for 3. So on the keystones, it might say all real numbers except 3. So what did you learn today? Hopefully you learned that theoretical probability, not that, probability is different than experimental probability. Because theoretical probability just takes it for what it is. You know, it has one head out of two. Whereas the experimental probability is based off of an experiment that you have done.